All right, well, we'll go ahead and get started. It is about time. So thank you for coming to the session. Again, my name is Ted Malone. We're going to talk about advanced analytics and how they are applicable to government agencies. Basically, how to enhance government services through the use of advanced analytics. So my role here at Microsoft, I am one of the few people that supports the federal government exclusively. My office is actually in our K Street office, but I actually live out west. I live in Arizona. So I spend a lot of time commuting here. So whenever I talk about some of the data and things like that we're going to show here, you'll kind of see where some of the things are coming from whenever you see some of the context that I put around the data there. So what this session is really all about here today, we're going to do, like I said, a very quick level set on when we talk about Azure government, what exactly it is that we're talking about. And I'm going to blow through those slides fairly quickly. But if there is something that you have a question about, please feel free to ask it. I'm more than happy to drill into anything that we see here. But then for the meat of it, what I want to do is talk about kind of the analytics revolution, how things are changing in the particular analytics field, the big data revolution, whatever you want to call it there. And then in that context, talk about the journey from data to information to knowledge to wisdom, and really how we're going to apply that to our government-specific problem set. And then talk a little bit about the data science process, what it is, what it's all about. And then, instead of talking through slides, what I'm going to do is I'm going to jump into a real-world application that kind of uses all of these things to really come to some conclusions about some very important stuff that popped up in the past here. So anyway, that's the session. And like I said, I'm going to cover these relatively quickly. But again, when we talk about Azure government, what we're talking about are some very specific services in our cloud that are government specific, either government from a federal perspective, government from state and local, or government from a contractor's perspective that's working with the tools there. So from the perspective of where we're at, 100% of the cabinet level agencies are using Microsoft's cloud, and more importantly, all 50 of the states are out there using it as well. So not only do we have all the cabinet agencies, but we have all the states. Bottom line is Microsoft understands the government customer, and we focus quite a bit on the government. If you look here kind of from a compliance perspective and look at the US Gov slide here, what you basically see is that if there is a compliance requirement for a government workload, we kind of deal with that. So we also deal with the CJIS from the Justice Department's perspective. We have basically 24 states that are signed up for this, that we have active CJIS compliance in place. And from a FedRAMP's perspective, basically all of the services that we make available, if they are not today covered in the FedRAMP scope, they will be very soon. The idea is we are making a commitment. If we have a service available to the government cloud, it will be in scope for FedRAMP. This is really important from an agency perspective and having to get that authority to operate from a cloud computing perspective. So just kind of be aware of all these things. From a DoD perspective, we also support level 5 information from a DoD cloud perspective. So basically, if you can put it in a cloud, we can handle it. So that's really kind of the idea there. The interesting thing too, and this is really interesting from being on the inside of Microsoft, we have the pace of innovation is just crazy. Every time I go to do a demo like this, I make sure the night before I look at my UI, because it is constantly changing. There are things that are new that, and I hate being in a group of people doing a presentation and going, wow, I've never seen that before. That kind of tends to make you think, well, what is this guy talking about up here? But we've had in the last 3 months 75 new releases, and the real key metric here, every 32 hours something new is being added to the cloud or updated or changed or something. So it is absolutely nuts. What does all this mean? Well, what it means is that whenever you go to solve the problem that you need to solve from an advanced analytics perspective, you can trust the cloud that we're putting together for that. So let's use all of that stuff and let's capitalize on this revolution that we all hear about as far as big data, advanced analytics. By the way, again, as I mentioned at the beginning of this, I am kind of Microsoft Federal's advanced analytics big data lead, but every time you see me use the phrase big data, I'm always going to put it in quotes. And I'll tell you the reason that I do that is I hate that phrase. I absolutely hate that phrase. But it's what everybody understands, it's what the market understands and everything else. So that's kind of my little way of rebelling against the system, if you will, and putting it in quotes. And my reasoning behind this is that this is nothing new. This is nothing different. This is nothing that we haven't already been doing. It just happens to be from a completely different context. So, for example, I have been working with Microsoft's data technologies, and I'll give you a little hint. The first version of Microsoft SQL Server, our relational database, that I installed, the operating system that I was working with OS/2 1.1. So that'll give you a little hint of how old I am, how long I've been doing this. I've been doing this for a long time. And so when people talk to me about the revolution, the big data revolution, advanced analytics revolution, and all of this, I kind of look at it from the perspective of, come on, this is nothing new, this is nothing different, we're just going at it a completely different way. And when people ask me to actually, back that up, this is actually how I'll do it. So this revolution, it's not as unprecedented as you may be led to believe. As a matter of fact, when you think about where we're at today, and you hear this all the time, when people are talking about using quote-unquote big data technologies to advance the government services and things like that, and you go to all these conferences that talk about this and sign up for all these courses that do these kinds of things, what they ultimately are talking about is things are moving so fast, if you don't innovate, if you don't pick it up, you're going to be left behind. And that particular concept has been around since time began. As a matter of fact, before this country was founded, back in the 1760s, I will say this is really where this all started, when we think about it. So if you think about the Industrial Revolution, think about in 1760, for example, what was happening? Well, there were a couple of things happening. First of all, the colonies here, the British colonies, the reason that we existed were twofold. First, that the history books will talk about, and you'll learn about, is the fact that we had a lot of people leaving England to flee religious persecution, things like that. The reality, whenever you got right down to it, was the fact that the New World offered a whole lot of opportunity in terms of manufacturing, textiles, things like that. There were a lot of raw materials here that were available for that. So a lot of companies existed to make textiles to send back to England, send back to France, basically send back to Europe. The thing is, in the 1700s, the late 1700s like this, what started happening was all of the human power started transitioning. There were steam engines that were invented. And so factories had an opportunity. They saw this steam engine that could actually replace people and could make things better. Just like we have today, what you had were people that saying, no, we don't want those machines to take our jobs. We don't want these things to happen. We're going to keep doing things the old way. And then we had all of the political upheaval and everything else. Gee, does any of this sound familiar, right? We had all of this political upheaval and everything, where what started happening was England started boy, if I could talk, we'd be doing really good. Started levying all of these fees and taxes and everything on top of this. And so there was one company, actually, the Boston Trading Corporation, that decided to take the leap and completely take all of their factories and replace the human labor with the machines, the steam engine. And interestingly enough, whenever all of the taxes and everything started getting levied against the manufacturers, they were the only company that could survive. All of the others went out of business, and then of course the revolution happened and all of those things. But the interesting thing was they adapted, they survived. Fast forward 100 years, and now you have kind of a new revolution occurring, where you had back in the day, if you will, prior to this revolution, the way to get goods and services from one place to another was basically horse and wagon or, the ship. And you basically, if you wanted to send a letter to somebody across the country or across the ocean, you basically packed it up and you either sent it via Pony Express or you sent it, in a ship over there. And then electricity started coming on board, and we started having the telegraph. And we had a company called Western Union that capitalized on all of this stuff and started sending messages using the telegraph. And then they were doing really well. They built a huge, huge business out of that. And then some group of people invented a thing called a telephone. And interestingly enough, the Western Union brass basically said, this telephone has, and this is an exact quote, no commercial use. And so they said basically, that's just a fad, don't worry about that thing, it's going to run away. And within 5 years, they were effectively out of business. Now, of course, they reinvented themselves and found other ways to do things, but their core business, sending messages from one place to another, was completely destroyed because they did not adapt. So in one case, you had the company that did adapt, and here you had the company that didn't adapt. Fast forward again, another about 80 years, and what you have is another revolution that comes along. And this one is really interesting, the digital revolution. What we think about is kind of the beginnings of the modern computer and things like that. But there was one company during that time that really had a lock on kind of all of the important technology, if you will, of the times, and that was, video and pictures, basically, Kodak, if you think about it. So all the news organizations wanted pictures. All of the media at the time, it was all about pictures. It was all about film. It was all about getting all of these things. People were experiencing all of this, and they built an entire empire around that. And then the whole digital film started coming into play, right? And Kodak did everything that they could to quash the idea behind the digital photography. And another company, their competitor, Fujifilm, actually embraced it. And what ended up happening, Kodak, if you think about a Kodak camera today, pretty rare when you stop and think about it. They completely lost their market. The point being, if you don't adapt to the challenges that you have in front of you, things are actually going to look very bad for you. The government is no different. If you don't adapt to the way things are going to work, what's going to end up happening is you're going to find yourself not being able to service the constituents, not being able to do the things that you need to do. And that brings us to today and this quote-unquote revolution that we talk about in terms of, big data, the cloud, machine intelligence. These things are moving at a very rapid pace. Innovation is occurring on an hourly basis. I mean, if I don't every single morning get up and read all of the news about something that I'm interested in, around the technologies, around cloud, around, analytics or things like that, there's something that I don't know. There's something that I don't learn. And it's just crazy just how fast things are moving. And so what we need to be able to do is we need to be able to find ways to embrace these technologies in order to accomplish the things that we need to accomplish. And that's really where the challenge lies. And that goes back to kind of the beginning of all of this in terms of when we talk about the Microsoft Azure Government Cloud, that is exactly the focus in building out the services that are there. It's all about enabling these big data technologies, these intelligence technologies, these cognitive services, and the ability to make it easy for people to deploy services around these things. Now, when you really stop and think about it, and I said this before, but I'll kind of say it again, it's nothing new. It's all about the journey of the data. And if you take a look at this chart, this is absolutely the way it's been since there's been data around. You take the data and you gain understanding of that data, you put some context around the data, and that allows you to extract information from that data. That information allows you to gain knowledge about that data, and knowledge enables you to have wisdom about what it is that you're doing. And then wisdom allows you to actually perform actions based on what the data is telling you. You have to go through this process. In the days when I started doing all of this stuff, it was an individual, it was a person who was responsible for all of these things. You had subject matter experts who had the knowledge about what the data looked like, how the data was modeled, and what it was that the data could tell us. And then what you did was you took that information that the subject matter expert created and turned that into knowledge. And then as a business or the government agency looked at it and said, well, I need to do X. Now that person had to go back with the context of X in their mind and go through this process all over again. For DBAs and for developers and people like me, it was a goldmine because I knew I had job security. I never had to worry about, not being needed, so to speak, because it was always available and always there. The challenge, though, today is data is moving much too fast. We can't have a person spend 6 months, 9 months, or whatever, trying to get that context and get that understanding. So what we need to do is we need to allow the machines to gain the context, to gain the understanding, and let the people take the output of what the machines are telling them so that they can have the wisdom necessary to perform the action that is appropriate. The little analogy that I like to use for that is the fact that a British guy by the name of Miles Kington said this. He says, knowledge is knowing that a tomato is a fruit. Wisdom is knowing not to put it into a fruit salad. Yeah, you laugh, but that's exactly what it is that we're doing. We're letting the computers tell us, don't put the tomato in the fruit salad, right? That's what this is all about. If I were to break down what Cortana Intelligence, for example, is all about, it's all about not putting tomatoes in my fruit salad. And, you look at this and go, well, that's crazy, but that's exactly what it is that we're talking about. Allowing the computer to get the context, allowing the computer to get the understanding so that we can focus on the action that's necessary. So, a microcosm of that approach is data science. So data science is something that has only kind of hit the mind share, if you will, in the last 5 years of organizations. And basically what we're talking about when we talk about data science, it's really nothing new. I mean, we've been doing this forever, but it's just a way of describing this process. The process is really simple. What question am I trying to answer? What data do I need to answer that question? How clean is that data? Or what do I need to do in order to clean that data? And then what is it about the data that allows me to make the decisions I need to make? What features does the data actually present from that perspective? And then let's create a model around those things. Let's evaluate our results from that. And when we're done with all of that, let's put all of this into production. And the interesting thing here, just like I was talking about with the other graph and the journey of the data from data into wisdom, this is exactly the same thing. It's an ongoing process. And what we want to do is we want to provide all of the tools and all of the capabilities necessary in order to make every step in this process relatively easy. And when I talk about relatively easy, just like they were saying, Tom said during his session earlier this morning about Azure Government and Cognitive Services, we're not talking about months to deploy solutions. We're talking about minutes to deploy solutions for that. And so with that in mind, what I'll do here is I'll spend a little bit of time just walking through a scenario that is a very specific real-world scenario using this process, utilizing the advanced analytics capabilities to show you how we can build a solution in minutes as opposed to days, weeks, months, years in some cases for that. So, now some of this is gonna be just absolutely, you're gonna look at this and say, well, duh, of course that's what that's telling you. But the reality is we have to go past some of those moments in order to get to some of the real nuggets of information that we're talking about. But basically, if we take a look at, Department of Transportation, NHTSA, the National Highway Traffic Safety Administration, is responsible effectively for saving lives. If you look at their mission statement, that's what the mission statement is. They save lives. How they do that is by analyzing safety on our nation's roadways and determining, what it is that they can do to make things safer. And your cars that you go buy, if you go buy a new car today, for example, the technology that's in the car that's driven by the federal government and by NHTSA specifically to make the car safer is absolutely amazing. But the interesting thing was the government noticed whenever they did an analysis of past years and 2015 data, they noticed that all of a sudden traffic fatalities have a sharp increase. And that doesn't make any sense because the roadways are safer and the cars are safer. So what is it about these things that are happening now? What's going on and what can we do about it? So in an unprecedented move, what the White House did was the White House put out a call to action. And this happened in August of last year, where basically the Department of Transportation through Dr. Patil and the U.S. Chief Data Scientist basically said, look, we're going to make our government data available and we need help in analyzing this stuff. And so to me, whenever I saw this, I said, this is a perfect example of something that we can do to prove a point. And that point being, how can we leverage all of these advanced analytics services, all of the data platform, and everything necessary in order to help answer this particular question. And so this is what the demonstration and everything here that I'm about to walk through, this is what it's all based on. I don't want to really call it a demo because it's not really a demo. It's an actual application that's created to answer this question. And it's utilizing all of the Microsoft services. That's what I do, right? I sell Microsoft Cloud services, so why not actually do it in a real-world example for that? To give you an idea of everything behind the scenes that allow what I'm about to show you to come to life, it really looks like this. So this is an example of all of Microsoft's cloud data technologies in one particular slide. And I know it's an eye chart, but you guys can download the slide and take a look at it here. But basically, it has everything from the on-premises database solutions through the cloud data solutions, through our NoSQL environment, through our advanced Hadoop, open source, Data Factory, Data Lake, all of these different things, including all of the cognitive services that we've been talking about here, as well as the delivery and consumption capabilities. So while not everything on this slide is available today in Azure Government, everything I'm about to show you is, first of all, and secondly, everything on this slide will eventually, very soon, actually be in the government cloud so that you can do all of these things. But what we're going to actually focus on is everything here on the right-hand side, because that's actually what people look at. But as we go through it, I'm going to talk about how we got there and the things that we did in order to actually get us to that particular point. So, we had the government tell us about the traffic fatality data. And they gave us all of the data from 2015. And one of the things that happened whenever I looked at that was, first of all, I noticed that we were missing some things that we were going to need in order to answer the question. Specifically, I wanted to really take a look at how weather impacted the traffic fatalities, and there was no weather information in the data that was provided. So I needed to enhance the data with that, number one. And then number two, it wasn't enough. We just had 1 year of data, so how could we actually make some calls on this? So what we did was we went back and we got 7 years worth of data, for that. So 7 years is a pretty good sample. It should enable us to actually do some really good work with that. So that's just kind of an idea to talk about there. And then the second part of this was once we got the data and once we put it into a form that we could then point the cloud tools at, specifically Cortana, and say, here's this blob of data. What is it that you can tell us about this blob of data to help us focus our analysis? Remember, what we're doing is we're asking Cortana, I need you to get some context around this data, and I need you to understand this data so that I, as the analyst, can focus on the important things of how to answer the question. And so that's really where we're going to start in all of this. So what I'm about to show you is, again, starting on the right hand of this slide, it's actually the Power BI tools, but I'm going to show you a component of Power BI that we actually call Quick Insights. And what Quick Insights does for us is it takes a look at the data and it attempts to find context and find some understanding of the data, and then things that jump out as anomalous or interesting, it will then tell us about. And basically this process, depending on how you model the data and depending on the size of the data and things like that, it can take a long time. So in my particular case, what I'm showing you actually was not that long because I'm only working in this case with 5 years worth of data. And secondly, there's really not that much to work with. There's less than, by the time you put everything I'm talking about here, there's less than 1 billion records that I've got out here. Really funny, right? I just used not much data, less than 1 billion, right? That's really how far the technology has come here. But you can see there's some interesting things that pop up, like this particular one right here. The year 2015 has a relatively steady % of total fatalities. Remember what the call to action was. Fatalities have increased. What's going on, right? And so what we looked at says, yeah, it's relatively steady. Well, what does that mean, actually? Well, let's take a look at some of these other things. And there's just a bunch of these little things that pop up here that Cortana found as being very interesting. Here's one that was the first thing that really jumped out at me as an analyst, was that if you look at this here, the interesting thing in the data is that there are clusters around the percentage of impaired fatalities. So basically what we do is we have a bunch of measures in the data. We have a fatality that occurred, and then we say, did that fatality result in some sort of impaired driving? Was it distracted driving? Was it, weather related? Was it a mechanical failure? Things like that. And there are some interesting time correlations around when people die whenever they are impaired. Now, as a person, you can hear that and you probably jump immediately to one of the conclusions, which is, well, of course, because when people are drinking all night at the bar, they're getting kicked out at last call, and you're going to see clusters of fatalities around that time frame. And that's exactly what the data is telling us, right? Yes?
How can that be across all the years?
So,
Cluster would be throughout the years.
well, but what we're doing, as you can see, we're not looking at the time frame here at all as far as the years go. We're just looking at the hour of the accident, right? We're not even looking at any seasonality here as far as months go. This was just something that Cortana looked at and said, there is something very interesting about this, right? So as an analyst, now what I have is I have a target that I can drill into, I can start looking at. So there's some other things in this as well that Cortana really told us. So, and I'm just going to point out a few of the things here. One that really jumped out at me. So is this one right here. So what this graph is actually telling you, and I know it's really weird with the wording and everything else, keeping in mind that I didn't do any modeling of this data before I fed it to Cortana. I just took the raw data and said, tell me what you can tell me about this. All right? Now, in this particular case, this value, this ST case, it actually stands for a fatality that a particular state is monitoring. The way that this data works, the federal government actually doesn't generate any of this data. What happens is it comes from the individual states. It actually comes from the law enforcement of the individual state. So every state has an ID associated with the report that talks about a fatality. So that's what this value is. And what they find is that in this particular case, Cortana told us that, you know what, in the majority of all traffic fatalities, there were no testing for drugs. Now stop and think about that for a second. One of the jobs of NHTSA, in this particular case, is to save lives, and it's around traffic fatalities. What we're trying to do is we're trying to understand the problem. How can we understand the problem if we don't take a very basic step, which is for every fatality, why don't we actually do a blood test, and actually decide were there drugs that were involved in this? And of course, there's a whole bunch of privacy concerns and everything associated with that, right? But now what this does is this gives the organization the ability to look at this and say, should we be thinking about legislating and making it mandatory that every traffic fatality have some sort of drug test, for that? And that's something that they have to look at. They have to weigh the issues, but they would never get to that point without actually having this data. And here we had the machine tell us, there's something very interesting right here to look at. And then I just want to point out a couple more, because what I'm going to do is I'm going to actually drill into what we do once we get these insights here. But here was another one right here that was very, to me, it was interesting. And the number itself doesn't mean anything, but when we talk about single vehicle fatalities, in other words, there were no other no other vehicle involved. It was a single vehicle crash that occurred and a fatality happened in this particular case. 9 times out of 10, when that happened, more than 90% of the cases, the blood alcohol level of the person involved was 0.96. Interesting, right? That's an interesting statistic saying, wow, for single vehicle fatalities, what we're seeing is that this particular number happens to be a magic number. And what it basically boils down to, if you get into the physiology of all of this, that's the point where you are really drunk, but you haven't gotten to the point where your motor skills are to the point where it's obvious. Your judgment is impaired and all of that, but you're actually to the point where, from a bartender's perspective, they wouldn't be able to look at you and say you shouldn't be driving. That's where that number comes from. So an interesting thing, right? We can look at that. And then the second one is that, none detected is a close second to that. In other words, we suspected that there was a problem, but we were proven that there wasn't. So maybe what we need to do is start looking into this a little bit deeper, for that. So that's just, some really interesting, statistics that came out of that. And I mean, there's a whole bunch more. Things like, if we just look right here, the fatalities have outliers. There's a correlation between the type of vehicle and pedestrian accidents that occur, things like that. So basically what we've done is we've had Cortana analyze this data And Cortana told us these are the things that we learned. Now, how do we get to that point? Basically, what we've done is, we have the data that we're putting into the cloud, and it really is as simple as clicking here, saying View Insights. Now, the first time you do this, it can take quite a bit of time, but the second time and thereafter, it's going to be pretty quick. Like in this particular case, it just refreshed, for us on this. But now that we have these insights, now that we have these starting points, what we can do is we can start using the tools in order to drill into this a little bit more. And we can see some of the things that we really need to see. So if you haven't seen Power BI yet, what I'm about to show you here is a tool called Power BI Desktop. If I can use my mouse correctly here. There we go. So what this tool is, it's a desktop application that allows me to connect to the data and allows me to do some interesting analysis against the data. So this particular dashboard is a representation of many of the things that you actually saw in the Quick Insights. So on the upper left-hand corner there, that's for the last 5 years, that's the trend of fatalities that are occurring. So we've had 200,000 fatalities over the last 5 years, and you can see the trend right there. It's actually trending upwards. If we take a look at that. And you can see the sharp jump that they talked about between 2014 and 2015. You can actually see that there. Now, of those 200,000 fatalities, 61,000 of those were impaired fatalities, and then 22,000 were related to distracted driving. I always like this, again, living out west, traveling here for my job, I always get a kick out of driving north on the Beltway, leaving Maryland or leaving Virginia and coming into Maryland, where if you're going north, basically the sign says, "Welcome to Maryland, put your cell phone down." And if you're traveling from Maryland into Virginia, it says, "Welcome to Virginia, turn off your radar detector." It's interesting what the states are interested in, right? But this distracted driving is something you see TV commercials about it, you see billboards about it, and everything else. But look at this. 22,000 distracted fatalities over this time frame, 21,000 weather-related fatalities. When's the last time you saw a TV commercial about driving safe in bad weather, right? When's the last time, if you have kids like I do who have recently gone through driver's education, when did they teach them about, what you have to do on driving in bad weather? I remember when I got my license, one of the things that they taught us was when, right after a rain, the roads are the slickest, because, hey, it hasn't rained in a while, all the oils are coming to the surface, and, we learn all of that stuff. They don't teach things like that anymore. As a result, you see these fatalities, things like that. But here are some crazy things that came out of this, things that I actually didn't believe, even after Cortana told me, said there is no way this can be true, and actually proved it by building this particular dashboard and this analysis and looking at it. So the top chart here is basically the fatalities by holiday, and we can actually see, some of these things make perfect sense. We know that we don't want to go out on the roads on New Year's Day. We know we don't want to go on the roads on Labor Day for that, because they're very bad days for that. Look at the third holiday. Yeah. Look at the third holiday. Now, this is all fatalities, all right? What if we were to flip it a little bit? And Cortana told us that, you better really, if you're going to look at the time frames, you really need to look at impaired driving for that. What if we were to change our holidays up? Look at that. So what this graph represents is the number of fatalities related to impaired driving under the influence for that. New Year's is still number one, but look at number two, the end of daylight savings time. What? And then the beginning of daylight savings time. So the end I can understand, right? You get an extra hour in the bar to drink, so we're going to take that. The beginning, I don't know, unless it has to do with the fact that, man, I had to get up earlier than I normally do, and I'm not really with it while I'm driving into work, you know. But these are interesting statistics for that. And Father's Day and Mother's Day are right there as well. Now, I looked at that and said, you know, this just can't be. But after drilling into the data and looking at it, it's very clear. It's a very, very clear trend in all of that. Well, what does that mean? Don't really know. I mean, I don't really have enough data to figure this out. Many of my friends that have looked at this have said, you know, well, come on, it's family get-togethers, very stressful, especially with nuclear families and things like that. So you really have some interesting things to worry about. Then another thing, if you recall the time frames for everything. Here's the hour of day. You know, these are the fatalities related to the hour of day. And what you can see is clearly the afternoon and evening hours are much worse on the highways than, you know, the mornings are, you know, for that. Just another interesting statistic, you know, to look at. The point of all of this is that now that we've been focused, what we can do is we can do some actual analysis of this data and really drill into it and see some interesting things. So, an example of that. So here is an analysis of the type of vehicle that's involved in the accident, you know, for that. And, you know, part of this makes perfect sense because four-door sedans are the most popular vehicle on the roadway. And then you look at the age of the driver. It does have a very, very sharp increase for younger drivers for all of this. So younger drivers are more involved in fatalities than other drivers that are out there. And drivers of, you know, the most popular cars are there. But if we were to make some changes to this, like for example, if we were to just look at motorcycles, you know, look what happens to the age distribution if I just change it to motorcycles. I have a lot of older people now that are actually, you know, dying on motorcycles. You know, people like me going through the midlife crisis, go out, buy a motorcycle, and go out and kill yourself, you know, for all of this. It's what the data is actually telling you. So here's some things that we need to do, right? So here's a perfect example of wisdom that can come from this data. If you have somebody purchasing a motorcycle and they are, say, over 40 years of age, because that's where the bump starts, maybe what you want to do is you want to mandate motorcycle rider training, you know, safety training. It doesn't happen across all the states, you know, for that. So just an interesting thing there. And then if you look at the states, I mean, Texas and California and Florida are the most populous states, so naturally you're going to see that. But if I highlight, for example, Texas, you know, the interesting thing in Texas is that my cars aren't as popular in Texas. As a matter of fact, while they are still the number one fatality, they are very closely followed by pickup trucks. Now, if you know Texas, that makes perfect sense, right? But nevertheless, you can see how that really changes. Whereas, you know, something like if we go to, you know, Virginia for that, what we see is basically, you know, cars are number one, and then after that, pretty much nothing. You know, so people that are dying here in Virginia are basically driving cars, you know, for that. And we can drill much more into that. But the point is that now that we have the data in this format, we can actually start doing some really good exploration. Remember that data science process, right? We have the exploration. We can start making some really interesting assertions out of this. So here's one that is very strange. So looking at this data, so this is data for Virginia here, and what this is basically doing is looking at all of the type of fatalities that are occurring and when they're occurring. Here was a very, very interesting thing that came out of this. As a matter of fact, when when I took this particular dashboard to NHTSA and met with the administrator, it was actually Dr. Rosekind of NHTSA, one of the things that he looked at right away was, this data is wrong. He looked at that because he knew the data, and he says, this data is wrong. I said, well, what do you mean the data is wrong? The data is the data. It's like, no, this data is absolutely wrong. He says, look at this. You're talking about more fatalities happening on cloudy days in Virginia. That can't be true because we don't have that many cloudy days, for all of that. It's like, well, okay, interesting. Let's drill into this. And then the funny thing was, after drilling into the data and looking at it, what we found is that for the year 2014 or 2015, there wasn't a single fatality in Virginia on a clear day. Every single fatality that happened in Virginia in 2015 happened on either a cloudy day or, rain, snow, something like that. Statistically speaking, that cannot happen. It's impossible to actually happen. So let's find out why. Let's actually drill into that and take a look at it. So, how do we do that? Remember that big graphic that I put up there and all of the things that we were talking about there? One of the things that we can actually do is for the traffic fatality data, we know where they occurred, right? We know the latitude and longitude of the accident. We also know that throughout the United States, there are weather sensors all over the place. And those weather sensors report back to NOAA every hour. So what we can actually do is we can take a stream from every single weather sensor in the United States, and we can feed it into our Azure cloud. Specifically, in this particular case, it's using Flume technology in the HDInsight service, which is the Hadoop environment. And what we can then do is, for every accident, we can look for the closest weather sensor to that accident. And then what we can do is we can look, based on the hour of the accident, we can look for the closest weather report from that weather sensor, and we can say, all right, what is the actual weather condition regardless of what was actually reported on the accident report. And that's what this is actually telling us. So this is a plot of every accident that occurred in Virginia in 2015 and the type of vehicle and everything else. But then we also have this detail level report right here that gives us every single accident that occurred and then what the police report read versus what the weather station said the weather actually was. So the first one that you see here actually tells us that the police officer said it was a cloudy day. The weather sensor for this actually said that the sky conditions were overcast at 6,000 feet. Basically, that's a cloudy day, right? So that one actually matched up. Look at the next 5. The police officer said that it was a cloudy day, but the weather report says the sky was blue for that. So now what we have is we have absolute evidence that, as Dr. Rosekind said, the data is wrong. But in reality, the data is the data, right? It was what was reported. So now what we have to do, again, if we want to really get some impact out of this, we now have a concrete thing where we can say, all right, what we need to do is we need to tell the state of Virginia that they need to spend more time impressing upon the police officers who are taking these reports that they need to be accurate about the reporting for that because it's really important for us. Or what we need to do is we need to incorporate this technology for, telling us what the weather actually is for that and not leave this up to, the human to tell us that. So a very interesting thing that absolutely came out of that. But then if we go kind of back to looking at other weather types, this one is a funny one. Okay. So again, remember, I don't live back here. I live out west. And I live in Arizona where it's always sunny and we don't have a lot of these problems. But my wife is from Colorado. And we lived in Colorado for a long time. And I got to tell you, I absolutely hated driving in snow. Right? It was just one of the things that I absolutely hate. As a matter of fact, when there's snow back here, I do everything I can to tell my customer, hey, let me come whenever it's not snowing, because I really don't like, dealing with the snow. So I figured, right, that if I look at snowy conditions, what I'm going to find is I'm going to find a whole bunch of fatalities related to snow, number one. Number two, it's going to be completely the inexperienced drivers where that is. So hey, here's a perfect example of something that we can do. We can train more people how to drive in snow. So if we ask the data, we say, you know what, show us what actually happens in the snow. And so what we see is that, first of all, over the years, the fatalities related to snow are actually on the decline. And then from a state perspective where it's most impacting, Michigan is probably the worst, and then you've got Illinois in there, you've got Wisconsin, you've got Colorado that's pretty bad for that. But the interesting thing was, look at the age graph. And just like I thought, we have some spike right here for younger people, but really what we're seeing is starting at about the 40, the same age that people die on motorcycles, right? We start seeing the same issue. We see a lot more middle-aged people that are dying in snow than we see in experienced drivers. And it gets even funnier when you look at the fact that related to snow, many, many more men than women actually die in snow. Now, I looked at this and said, I don't get this, I don't understand it. My wife looked at it and said, well, of course. I'm like, well, what do you mean? I don't understand. What are you trying to tell me? She's like, you guys all think that you're invincible. You jump in the car and you drive. The rest of us are smart enough to know to stay home, in cases like this. Perfect example, right? Looking at this. The point that I'm making in all of this is that I never would have been able to even get to this point as an analyst if Cortana hadn't pointed out something to me that was interesting. This dashboard, as it sits here, is not. However, they are working currently on one internally that they're going to be making available to the public. However, what I can tell you is that if you send me a note, I'll be happy to share this with you because I've made it publicly available. Okay? So, ted.malone@microsoft.com for that. So again, here's just some interesting statistics on this. But we can also get really involved and really in-depth with some of the data here. So we can take it much beyond this kind of superficial, hey, Cortana told us to look at some things, so we did some analysis based on that. But one of the things that the White House call to action actually said was that we are finding that there are many, many fatalities in underprivileged neighborhoods. Does income have an impact on whether somebody dies in a car accident or not? That's one of the questions that the White House specifically asked. So if you think about that question for a second, what does it actually involve? If you go through that data science process, what do you need to do in order to answer that question? Well, the first thing you have to do is you have to have all this fatality data, but then the second thing that you need is you need to correlate that with the income levels of, and in the case of what the White House asked specifically, was does the neighborhood that the accident occurred, does it impact the accident? Or does it impact the fatality? I look at that and say, well, let's actually go out and answer that question. So one of the really cool things that we can do with our cloud technologies and the fact that we have great partnerships with companies who are really good at this kind of stuff. So by far, from a geographical analysis perspective, the number one company out there is Esri. I mean, Esri is involved. Every government agency uses Esri, ArcGIS for their tools and everything else. So what we did was we entered into a partnership with Esri where they baked in a lot of their tools, specifically around GIS analysis, into the Power BI tools here. So, for example, if I take a look at this, what I'm actually going to see is what I'm looking at here is in Power BI, I am looking at Virginia fatalities for the year 2015, and I have it overlaid with the neighborhood demographic data. So the darker the color that you see here on the left, the more distressed, economically distressed that particular neighborhood is. And what the White House wanted to know was, does the neighborhood actually impact how the accidents occur? So if we actually drill into just an area, for example, around Richmond, and take a look at it, what you see basically, these are all the fatalities that happened in 2015 around Richmond, and you can see it has absolutely no correlation to the neighborhood. Now, when Dr. Patil asked that question, my response to him was, that's irrelevant. It's an irrelevant question. Here's the data to prove that it's irrelevant. But what would be relevant is if I could get the demographic information of the person who died or the driver of the vehicle, right? That would be what would answer that question for us. So even though that data is not publicly available, one of the things that NHTSA is actually working on is the ability to do that correlation. Yes? Beautiful. Yeah, so that's an excellent, excellent question. And that is one of the, so the comment was, can we actually match it against the infrastructure? The poorer the neighborhood, the worse off the infrastructure is going to be. Or, like I said, I used to live in Colorado. Colorado roads are notoriously horrible because they don't spend as much money on their highways as other states. Where I live in Arizona, people come to the highway and think, man, this is glass because it's so well maintained, things like that. It's interesting how the states handle that. But one of the things that we have the capability to do here with the Esri integration is we have the ability to actually take a look at the reference layer, and then instead of, in this particular case, looking at diversity and things like that, why don't we actually add, and what would tell us, right, would be the home value in that neighborhood, right? That would be a really good indicator for that. So let's actually use the median home value for that, and let's apply that instead. And so now, when I go back, so now the darker the area, the more expensive, or I'm sorry, the other way around. The lighter the area, the more expensive the homes in that particular area are for that. And so what you can actually see here, once again, no correlation. Very, very, but see, look at how quickly I was able to do that based on the question, right? This is the power of cloud computing technologies, being able to do this. 5 years ago, that would have taken, a 6-month project in order to go out and actually do that. And we have the ability now to do this absolutely with a click for that. But these are just some really good examples, of what you can do. And now that I've done that, so for example, I can do the same analysis instead of in Virginia. Maybe what I want to do is take a look at California, for that. And I can definitely see, if you look at some of the clusters where the population is, but as I drill into that, you can start seeing that our clusters actually exist around population centers, and that makes perfect sense. So let's take that concept and drill into that even more. So one of the things that we can do here, again going back to Virginia, is we can do some spatial analysis against this data, and we can determine, and it's kind of going out and doing that right now, and the network connection is a little bit slow here for that, so it's taking a little bit of time. But basically what this is showing us here is that for Virginia, we have some, and that's what the graph on the far left-hand side says to us, we have some very specific patterns related to traffic fatalities in Virginia. And then, if I broke it down even more, Like, let's say, for example, I wanted to focus on motorcycle accidents. Do we have any type of clusters of data for motorcycle accidents in Virginia? And we absolutely do. And the interesting thing about that, and it's kind of hard to really grasp here quickly, but this is vertical when it should be horizontal. But that's just the nature of the way the visualization works. So if you put that over on its side, it basically matches up to the map of Virginia. And what we see is that here in Virginia Beach and Norfolk is where we see the most, fatalities related to motorcycles. Now, think about that for a second. What is the demographics of the area of the people that are riding motorcycles, right? They're absolutely, the invincible, kind of that whole approach for that. And it shows in the fatality map and the cluster of that. So, again, something that we can possibly take a look and solve this particular problem and look at that. And again, it's using advanced analytics. So by the way, what all of this is built on behind the scenes, so this is data that's being processed by HD Insight as far as the accidents go and the weather conditions and all of that. But the actual analysis of the data that you see, all of these graphs, this is actually R. So Microsoft R server behind that. And the reason that I chose R to do this is because I happen to be very, very competent with it. I could have used any other language to get there, but R got me here quicker. The point being is that as the analyst, I have my choice of tools that I want to use in order to give me some of these capabilities. And I can go on and on and on and on like I already have on this data. But the bottom line is that we now have the tools in front of us to be able to very quickly ask a question of the computer. In this case, Cortana told us, here's the things that you want to focus on. And then what we were able to do is take that focus and drill into a very specific executive presentation where now they have the capability to look at the data, to actually analyze it deeper, and more importantly, when questions are asked, to be able to immediately look at the data and answer the questions instead of, I'm going to get back to you in 6 months. Hey. Uh-huh.
Was that a real-time pull from S3, the most recent, or is it like a batch data which is done?
So in my particular case here, this was actually built real-time with that. That's actually why whenever I switched, it actually took a little bit of time to pull that in because it went out to their server in order to do this. Now, I can't tell you for sure that it is their most recent copy. My guess would be that if you owned ArcGIS, you would probably have a more recent version of that. So they probably have, deltas that are built into that service. But nevertheless, it did go out to their servers and pull that in. This was ArcGIS that actually did that. It was not Microsoft, that did that. So. All right. So basically, that's the application that I wanted to show you. I wanted to just spend a little bit of time, show you some of these interesting insights that I thought were interesting. And I don't know really anything about transportation other than, I get on the road and I drive to my destination. Yes?
I'm sorry, okay. But what was the conclusion of the study?
So the conclusion basically was that we don't have anywhere near enough information in order to answer the question as it was proposed. But what we now have is the ability to actually know what data we need to get. So the first one was we obviously have to do more testing on drugs for fatalities because we're not doing that, drugs and alcohol related to that. So we don't know if drugs and alcohol are a bigger problem than we think they are because we're not doing tests. So that's something that we have to do in order to get a better analysis of this. But then the other thing was that while distracted driving is a problem, weather-related fatalities are as big of a problem. So we need to spend more time doing education around driving in bad weather and doing better public service analysis of that. So an example of that, again, going back to where I live, there is a section of Interstate 10 between Tucson, Arizona, and Socorro, New Mexico, where the desert is just absolutely dry, and we have very bad dust storms. And when the dust storm comes through, you cannot see. The visibility is absolutely zero. And so what happens is we have a lot of fatalities on that stretch of road. So based on knowing that we have these fatalities, what the department used to do would be to, whenever the weather report got to the point where, hey, we can't see anything on the highway, or they had an accident that was fatal, they would shut down the highway. Fast forward to now, what they actually do is they do some predictive analytics. They look at the weather report, they look at how dry the area is around the interstate, and if the wind is forecast to be above 20 miles an hour and the ground is dry enough to generate the dust, they will actually proactively shut down the interstate. And as of right now, there have been no fatalities in that particular section of the highway. And we're actually projecting, if this continues, and they actually proactively shut it down, that there will be no fatalities on that section in 2017, for that. So, and I think that's a major win, right? So that's just an example of what you can do. Same thing in upstate New York. A lot of fatalities around the lake, around bad weather days. Snow, blowing snow and ice and things like that. Why not do a predictive analytics run against the data saying, hey, it's predicted to be icy on this stretch of road. Why don't we shut it down before it happens as opposed to after the fact? So being very proactive about it. Yes?
If you got a completely new data set about which you know nothing about, how can you use Azure to start doing the analysis, building the models?
Right.
What is the
So the question is, what if I had a new data set that I didn't know anything about? How could we do that? That's exactly what this was to me. I had absolutely no knowledge of what it was that I had. I actually had a document that was 136 pages of field names and where the data came from, but I had no knowledge about the context of that. So what I did was I just put it all together, pointed Cortana at it, and Cortana found a bunch of things about that I then drilled into and learned about. What does this thing mean? What is this value? What does it actually mean? And then that's how I started this process, and that's actually how we got here, is I let Cortana kind of do the initial discovery. And I'll be honest with you, probably 80% of the stuff that Cortana found was completely nonsensical, right? But that 20% was gold. That 20% is what built this whole presentation. So I didn't know anything about the data at all, Didn't even know what it looked like and didn't understand it. And whenever I tried to look at it from a relational perspective, it made no sense to me at all, So, and it helped. So. All right, well, I think we are pretty much right at time here. We've got the Ask the Experts session down in the atrium. It starts at 6 o'clock. I know there's going to be some refreshments and a few things else down there. But I want to thank you guys for coming to this presentation. I really appreciate the interactivity, the questions. And again, send me a note. I'll be happy to share this with you, number one. And number two, I'm here. I'll be down at the Ask the Experts as well. So again, I really appreciate your time and thank you for coming. So.